All right, so let's take a look at part D. Part D, we have to graph all the lines and state a conclusion. So let's go ahead and list all the lines that we're graphing. So line 1 is defined by the equation y equals negative 2/3 x plus 2. Now what does this tell me? Well, this equation tells me that the slope of L1 is, let's call it M1, the slope of L1 is negative 2 over 3, which means I'm going to rise negative 2, which is equivalent to going down 2 units and run 3. And then the y-intercept of line 1 is 2. Okay? All right, and then for L2, we arrived at the slope-intercept form of y equals negative 2/3 x plus 4. And what does this tell me? It tells me that the slope of line 2, M2, is negative 2/3, which means we're going to rise negative 2 down 2 units and run 3. And then the y-intercept of line 2, B2, is 4. And then for line 3, we had y equals 3 half x plus 7 over 2. Okay? And this means that the slope of line 3 is 3 over 2, which means we're going to rise 3 and run 2. And then the y-intercept, B3, of line 3 is 7 over 2. Okay? All right, let's go ahead and graph all these three lines on the same coordinate system and then state our conclusion. Okay, so now if you notice, one of our y-intercepts has 2 in the denominator, so that should affect my calibration of my y-axis. So instead of going by ones, let me calibrate by 2's on my y-axis to compensate for that fractional component of B3. All right, so 1, 2, that's 1, 2, 3, 4. Okay, 1, 2, 3, 4. I went as high as 4 because that's the biggest y-intercept I have here. And on the x-axis, 1, 2, 3, 4. All right, so this is my x, this is my y. Okay, let's graph line 1. For line 1, B1 is 2, so the y-intercept for line 1 is 2. Let's graph that point. 2, and then we're going to rise negative 2, go down 1, 2, and run 3, 1, 2, 3. So these 2 points define line 1. Okay, I'm going to draw line 1 using a red line. All right, so basically draw a line through the points. Shoot that point like that. Make sure it's as perfect as possible. All right, so there goes line 1. If you want to make sure your graph is correct, you can use multiple points. So like we went down 2 and over 3, we can go up 1, 2, and back 1, 2, 3, just to have more points. The more points you have, the more accurate your curve is, okay? So that's line 1 we just drew there. Now what we're going to graph next is line 2. So let's label this. This is L1. All right, line 2, let's graph this one in green. The y-intercept is 4, so start from 4. We have a rise of negative 2, so we go down 1, 2, and over 3, 1, 2, 3. Okay, you notice that these two lines have the same slope. Okay, so we went down 3, forward, down 2, forward 3, so we can go up 2, 1, 2, and back 1, 2, 3, just to have another point of reference. Okay. All right, so now let's go ahead and draw sketch the line. Let's make this one green. All right, so graph a line through the points. That will be line 3. Okay, I mean line 2, I'm sorry. So there goes line 2. All right, now we're going to go ahead and graph line 3. Let's label it first. So this is L2. Okay, and then L3 has a y-intercept of 7 over 2. Now that's messy to graph. 7 over 2 is the same thing as 3.5 in mixed numbers. So where's 3.5 is right here. How about we graph this in blue? So this is 3.5. So we're going to rise 3 and then run. We're going to, let's see. We're going to rise 7 and then run 2. Okay, rise 7 units and then run 2. All right, so if I rise, I'm sorry, we're gonna rise 3 and then run 2. Okay, rise 3, run 2. So we can go 1, 2, 3, and then run 1, 2. Okay, if you have a difficulty, you end up outside the graph, you can do the um, reverse direction. Instead of going up 3 and over 2, you can go backwards. You can go down 1, 2, 3, and go back 1, 2. Okay, you're gonna end up with at another point that's on the same line. So rising 3 and running 2 is the same thing as falling 3 and backing up 2. All right. So there goes line 3 right there. Let's go ahead and sketch the line. Let's make this one blue. All right. So there goes line 3, L3. Okay. All right. So now what we're going to do is we're going to just put some geometrical marks on them just to indicate the relationship between the lines that can also aid us write down an appropriate conclusion. All right, so let's see. This is L3, line 3. Okay, if you notice, these two lines are parallel. L2 and L1 are parallel, so this line is parallel to this line. And what do you know about L3 and L1? They're perpendicular, 90 degrees to that and that. Okay, so what conclusion can we state from the graph? Conclusion from the graph, we can clearly see that lines 1 and 2 are parallel. Lines 1 and 2 are parallel. Lines 1 and 3 are perpendicular. L2 was supposed to go through the point 3, 2, right? But is that the case? Where is 3, 2? Let's see if L2 goes through 3, 2. So 3, this is 1, 2, 3, and then go up 1, 2, down. This is 3, 2. L2 goes through 3, 2. It's a requirement. If it didn't go through 3, 2, that means our graph is wrong. And another requirement was for L3 to go through what? L3 was to go through negative 1, 2. Is that the case? Negative 1, and then up 1, 2, down. Perfect. L3 goes through the point negative 1, 2 also. Okay? So L3 goes through um, negative 1, 2. Since all this work, that clearly shows that our graph is in fact correct. All right, so there you have it. Well, thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking up here, and please post the comments to tell me what you think about this clip. More clips can be found on math2serve.com. Thanks again, and have a wonderful day.